Hi, CPSC 386. I'm going to talk to you today about Python virtual environments. Python virtual environments are a way that we can organize all the requirements for a Python project and be able to have different versions of the same library installed on our computer, or to be able to distill all the library requirements in a repository so that if you move the repository from one computer to another or share it with somebody else, they'll be able to rebuild that entire environment with all the libraries needed so they can run your code. This is really useful for us because whether or not you're using Ubuntu or Windows or Mac OS, we're all using Python, and we're all going to be using Pygame to build games. So we know that's the first library that we're using. So there's how do I get that library installed? So far, we've always used the package management system, or what I've talked about in class, the package management system for Linux to install additional software. But what about software that's specific for Python? The most common way to install that is with pip, PIP. And if I use pip, I can install Python packages for the user, myself, or I can install it on the system for all the users there. But if I write a program using those libraries I installed with pip, and I send it over to your computer, or I share a repository with you, you'd need to know how to, what packages I used. And this is why Python virtual environments are just a really handy tool. Let me start by describing to you what I have here. I just have my text editor open, and I've got a terminal open. I'm in an empty directory here, and the one I'm going to start out is by using the Python command to create my first virtual environment. Now, by the way, I'm doing this on a Macintosh, but everything I'm going to do here is stuff that will work 100% the same on Ubuntu Linux, because I've tested it out. The other thing I'm going to say is, yeah, typically we type Python 3 to make sure we're running Python 3, but I have aliased my Python command so that when I run Python, it is running the same version of Python that is on Ubuntu Linux. So let's start by creating a virtual environment. In the long, long ago time, virtual environments were a separate add-on package to Python, but nowadays it's part of the system, and you can say Python -m venv. This is the most common way you run it. Let me tell you what this command does. And in case you run this on Linux and it doesn't work, it's probably because you need to say Python 3. So I'll do it this way the first time. The -m venv is saying use the venv module. This is part of Python's standard library. And if I bring up venv so you can see what I'm talking about, over here in the Python standard library, there is venv, and all the documentation. It's something you should go through and read and understand. It's really handy to know all the ins and outs of it, but I'll just give you a brief tutorial right now. So you're saying Python, use this module venv, and then execute it. And what I want you to do is to put in this, is to create a folder, a directory called env, and to put a virtual Python environment into it. Again, this directory is empty. When I run this command, what it will do, it will create a folder, a directory called env, and inside of it, it's going to put a whole Python virtual environment in there. Inside that directory, you're going to have bin for programs, include for header files, lib for libraries, and a configuration file. What we're going to do is we're going to activate. We're going to activate this virtual environment by using source. It's a shell command. What it does is it reads that file and takes all the information in that file and throws it into your own environment. And it will change your environment so that you're using the virtual environment defined in that folder. I know this to be true because it will change your prompt. Now, my UI here is a little bit buggy, and I have two sets of parentheses. If you do this on a Linux system, you'll only see one set of parentheses around env. So other than changing the prompt, what has this done? If I type which Python, it's going to tell me that the Python that's currently available to me is the Python that lives in this folder. If I deactivate, my prompt will change And if I ask which Python am I using, it'll now tell me about the Python that I typically use. Now, again, I'm on a Mac, so it's going to give me a slightly different path. But if I was on a Linux system, it will say something like user bin Python. So again, if I activate my virtual environment, all of a sudden Python lives over here. If I deactivate and I ask where my Python is, it's going to say it's in the system directory. So using this this Venv module allows me to create this separate Python installation. So I activated it. You say, well, what other things can we do with this? Well, inside of env bin /bin, there's the activate scripts. There's also pip. Pip is a tool that allows us to install Python packages. Python is not only is a nice programming language, but it's a really vibrant community. There's a lot of people writing all sorts of great software for Python, and there's a website called the Python Package Index, and you can search it to find all sorts of libraries that people have written, various quality, some of them incredibly great quality, and some of them, not so great. But you can search. You can say, oh, you're interested in I don't know, astronomy. And there's going to be a whole bunch of different packages here that have to do with astronomy. You can say you're interested in, oops, I accidentally clicked on something. You could say you're interested in Spotify. Oh yeah, there's a whole bunch of packages that somehow connect to Spotify. Or maybe you're interested in talking to a third-party search. Oh, like GitHub. Maybe there's a way that you could write scripts or programs to do. There you go. So there's just all sorts of interesting things that you can explore. What we're interested in is Pygame. And Pygame, sure enough, is right here. Now, Pygame has been around for a very, very long time. And there's many, many different versions of it. When we use pip to install Pygame, it's going to install the latest version, which is the version that we want to use. And that's going to be version 2.61. How do I install it? You just use this command right there. So you can click that, copy it, come over here. I make sure that I'm in my virtual environment, and I paste that command. And it's going to reach out across the internet, download the Pygame package, and install it into your virtual environment. How do you know Pygame is installed? Well, if I go over to the Pygame wiki, they've got the getting started here. I just clicked on getting started. You're gonna say, oh, why don't you try running aliens? So come over here and say Python and Pygame samples aliens. Now, if I've got Pygame installed, it should work. And I should see aliens. Oh, that's really loud. That was very loud in my ears. So it did work. Now, if I deactivate and I try to do the same thing again, well, it shouldn't work because I don't have Pygame installed in the system. In the environment for my, the base system does not have Pygame installed. So let us do this over again one more time. So I've deactivated. I'm not in my virtual environment right now. I'm going to remove that folder. And what I'm going to do is I'm going to essentially do the homework exercise that I have set up for you guys on Canvas. And I forgot to get that loaded up, so I'm going to load it up real fast. And we'll work through it together. So I have a little exercise to make sure that we all are able to set up our own virtual environment and go through the steps. And the steps are there to ensure that no one gets stuck, they get some practice in. And it's called Hello Pygame. Accept the assignment. And I've got my little repository here. When you create a virtual environment, you never, ever, ever commit the virtual environment into a repository. You don't need to put it into your repository because it's just generated by Python. So let's start by saying, okay, I've got an empty folder here. I've got my CPSC 386 folder. I'm going to clone this repository onto my computer. And it's cloned. So I've go into that directory. And what we want to do is follow these instructions. Now, I've written out all the steps here with the commands so that you could blindly copy and paste them. But I'm hoping that you would not just blindly copy and paste them, but you can distill this down to your own set of notes or something so that you understand how you can create your own virtual environment and be able to figure out how to activate and deactivate your virtual environment. So to start off with, we need to create a virtual environment. Now, the standard way of doing it is by naming your virtual environment env. The name here could be anything you want. Say snafu. When you run the command, it's going to create a folder called snafu and your virtual environment is in it. I don't recommend doing this, but it's just FYI, it doesn't have to be named env. It's just a practice. Now, some of you might say, well, I don't want to use virtual environment. I want to use UV or something else. I'll say, yes, there are alternatives. They're newer, they're fancier, they have there are certain strengths to them. But I would like us all to use virtual environments because it's very common, it's established, and so let's practice using virtual environments in our class. And if you want to use other stuff outside of class, you're more than welcome to. I'm not saying that virtual environments are the best. I'm saying it's a good common denominator amongst all of us so that we can learn how to use this technology to write interesting software. So instead of naming it snafu, let's do this for real. Python, let me spell that correctly. Python 3 VM. Won't call it snafu, I'll call it env. Again, by convention. That's step one. Let me move this aside so we can look at them both at the same time. Step two, activate your newly created virtual environment. So we activated the env bin activate. Great. I can look at my prompt and I see the name of the virtual environment right there. Now we want to install Pygame. So I say pip install Pygame. Again, it's going to reach out across the interwebs, install it. The first time it does this, it might take a little bit longer because it actually has to download it. As you can see from the output there, it's cached because I've done it before on this computer. So there's a copy locally stored. Once that is done, I have Pygame on the computer. So now we need to have a program. There is a gentleman by the name of Al Swigart. He's got a whole book called Making Games with Python and Pygame. It's got a whole bunch of cute little games in there. And we're just going to borrow one of his. And I'm just going to copy and paste this command. This is going to use the program wget. Wget is a command line web browser that will just fetch stuff off the web. So using wget, it will download the file from Mr. Swigart's GitHub page, GitHub repository. And now we can see that we've got this file slidepuzzle.py. So the next step is to add Al Swigart slide puzzle to your repository and commit it. Essentially, the whole point of this project is I want you to imagine that you're making a game. You're going to put all this stuff here, create it, make it run, do all that stuff. And then I'll be able to clone your repository, or your friend or yourself will be able to clone your repository and then be able to run your Python game. So let's just go through all the steps. Git add slidepuzzle.py. I'm going to commit slidepuzzle.py and say something like initial import from Al Swigart's page, etc., etc. Great, it's committed. Then I want to add a shebang and change the permissions. Let's change the permissions first. Let's first see what the permissions look like. It's just read write. So I say chmod user group and other execute. Double check that again. Perfect. Now it's executable, but we need to have the shebang at the top. So let's open this up in our favorite text editor. And right at the top, on the first line, put the shebang. Now, some of you are doing this, putting it there. No, it has to be on the first line. Some of you are not doing it right. It has to be # exclamation mark user bin env python 3. That's the way it works. Then you save it. Now that it's saved, we did the shebang. We should run it to see if it works. Now, there's always a little bit of a lag when you run one of these games for the first time because it's bytecode compiling all of the Pygame library. But the second time you run, it'll be a lot faster. So now we see we've got a nice little game here, and it works. And we've got a high degree of confidence that everything is A-OK. So I'll just quit this game. Our next step was to freeze. Now this is a key step. Pip freeze is going to Pip is going to ask itself, hey, what's installed in this environment? And if there's anything that's been added onto the base environment, it's going to spit it out. So if I type pip list, it's going to show me all the different things that are installed in this environment. You can see two things are installed. One is pip, and the second one is Pygame. If I do pip freeze, it's going to put the output's going to be such that it shows us the package name and then tells us the version. And so what I'll do is use output redirection. This is a Unix thing where I can take the output of a program and write it to a file. I'll say requirements.txt. And again, this is another convention. It's a convention to have a file called requirements.txt, which explains what is required for this Python project. And so inside that file, if I open it up in my text editor, you can see it says Pygame, and it shows us the version number that we're using. That's all that's contained in that one file. Now, some of you might have a lot more. If you have a lot more, you might have installed too much stuff, or you might have installed Pygame into your system rather than a virtual environment. I will look at what's inside your requirements.txt to kind of give you some feedback via your score about whether or not you're doing it the right way. So please be conscientious that you're doing this in a virtual environment and you're freezing your virtual environment. Once you've done that, well, now we need to add. This is, oops. Gosh darn it. Let's do that again. We're over here on step 8, right? Now we need to add our requirements to our repository because next time push Q. When we add our requirements to our repository and commit it, now it's part of the entire repository. And if I clone it or somebody else clones it, they'll have the recipe to rebuild your environment. So now that it's added, let's commit it. Message initial of Python. That's good enough. And then we push this off to GitHub. Okay, we're done. That's essentially the bare minimum. There's some other nice things you should consider exploring. One is to ask yourself, okay, well, if I've got a whole bunch of Python code here, maybe I want to lint it, or maybe I want to use a formatter or something else. If you're going to use PyLint or any of the linters, you need to have PyLint or the other linters or whatever linter you're using installed into this virtual environment. So I have to say pip install PyLint. Now you might ask, like, why do I need to? I already have PyLint installed. You know, like for instance, myself, I already have PyLint installed. Why do I need to install it again? Well, this PyLint, the one that's in the system, notice that the path is opt local bin PyLint. That one doesn't know about Pygame. So if it tries to lint, it tries to look at your code and you're using all sorts of Pygame stuff, it's just going to be like, I don't know what you're talking about. It's going to throw a whole bunch of negative feedback in your face. So instead, you install PyLint into this virtual environment. And now this PyLint will know about Pygame. But if you do this, you also need to refreeze. So if I do pip list, now you can see I've got a whole lot more stuff installed in this virtual environment. This is totally okay. So if you decide to install Pylint and these are the things that you have there, that's okay. In fact, that's a good sign. I'm glad that you're doing that. So I'm going to pip freeze and output this out to requirements.txt. And if I use git status, you can see that those files are modified. So I'm going to commit requirements.txt and say created requirements with Pylint. And I'm going to git commit slide puzzle. Say I added a shebang. Oh, forgot exclamation marks. No. Let me try that again. There we go. So I've installed Pylint. And if I want to do something nifty, well, I can just start Pylinting slide puzzle right away. And you'll be like, wait a second, I thought you told me it will know about Pygame. Or does it? Well, there's a whole bunch of stuff here about... this code isn't like the best written code. But here's the part I want to show you. Unable to import Pygame. Okay, why? Well, I installed Pylint, I installed Pygame. It's in this virtual environment. Why can't it find it? Maybe you need to deactivate first and then reactivate. What would happen then? Okay, so then we look to see if it can find Pygame. So much. Okay, module Pygame has no init member. So if I look carefully, it's going to say things like Pygame has no init member. That's weird. Pygame does. Let me see if I can find other Pygame problems. Pygame has no quit member. It does have a quit member. If you look more, you're going to find out that all the Pygame stuff, or most of the Pygame stuff that it uses, it's going to complain about. This is because Pygame is actually not pure Python. It's C code that Python is accessing. And this is rather dangerous. So the linter is trying to be conservative, and it notices that Pygame is a C library, and it says, okay, if it's a C library, I'm not going to load it because I don't know what's going to happen if I go into that library. So this is considered an unsafe load from Pylint's point of view. That's why I give you some tips here about how you can generate an RC file. An RC file is a configuration file. RC stands for run command. But it's a very common Unixism to say if I need to configure some program to behave a certain way, you create an RC file. We can ask Pylint to generate an RC file. And once we have that RC file generated, we can open up that Pylint RC file. And I'm telling you, if you look for unsafe load extensions, if you change this from no to yes, all of a sudden Pylint will be able to look at Pygame's library, because Pygame, like I said, is a C-based library. So this little change to how Pylint works. Oops. I mean, if you run Pylint now, it's not going to give us completely different feedback because it was able to load Pygame, and now it's saying a whole bunch of stuff. Not only is this code messy and things are not named according to the right conventions and, according to PEP 8, but, now it can find Pygame and tell you a whole lot more about it. Now, if I deactivate this, I go back to my regular environment. The repository doesn't care if you're in the virtual environment or not. Now I just did create another file, so I'm going to add that, commit it, and push it. So now let's imagine you've pushed this work off to GitHub and you're wondering what I'm going to see, or what your friend might see. So I'm going to delete this. Delete all the stuff that we have here. It's gone. There's nothing there anymore. We're going to start from scratch. But remember, it's not really scratch because we made all those commits. And if you're not sure, if I come back over here and refresh this page, our repository, you can see it's got the PyLint.rc, it's got the requirements.txt, it's got the slidepuzzle.py, it's got the comments I made. So now I've pulled this repository back. It does not have the virtual environment because I never added the virtual environment. In fact, I have the git ignore there specifically to stop you from putting a virtual environment in there. But I want to recreate this so I can run it. Because right now, if I just run slide puzzle like this, it's not going to work because it doesn't have Pygame. So now I can just create that virtual environment. I can activate that virtual environment, but I don't need to manually install each piece that you had in your virtual environment. Instead, I can say pip install -r requirements. So pip is smart enough to look at the requirements file and say, oh, you want that package and you want that version. I'll go onto the interwebs, grab all those things and install them. And once it's done that, everything will run just fine. So that, in a nutshell, is how you can work with Python virtual environments. Again, it's not bad, it's not good. It's just, this is a very common way that we can configure the requirements for a Python project and we can manage them. And you can write you can write a game with Pygame version 2.61 today and then maintain it at that version. And you can start another project the day after tomorrow using a newer version of Pygame or an older version of Pygame and be able to manage those two projects independent of one another on the same computer. Anyhow, I hope you found this explanation, this demonstration useful. And now it's on video so you can watch it over and over and over again. Thanks again for watching.